Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Safety Risk Assessment and Management Procedure. Purpose, Scope. The main purpose of this procedure is to enable companies' asset owners and project managers to identify and assess those safety hazards and risks arising from their activities, from existing facilities or projects, that require management in order to comply with regulatory requirements, comply with company policy and business requirements, assess the risk imposed by KOC activities, existing facilities and projects to personnel, public, environment, business, or assets. Ensure that adequate measures are taken to eliminate or reduce those risks to a tolerable and as low as reasonably practicable, LRP, level. Another important purpose of this procedure is to provide the philosophy that underpins the application of the risk assessment and management methodologies to safety. In doing this, the procedure provides a sequence in the use of these methodologies to the different stages of the life cycle of KOC activities, existing facilities and projects, that is from seismic through design, operation and abandonment of a facility. The procedure provides suitable and sufficient risk assessment and management effort, covering all the approaches to risk assessment and management, and reflecting a range of detail of assessment from the lowest qualitative risk assessment, gray, through semi-quantitative, square, to the highest level represented by a full-blown quantitative risk assessment, QRA. It is worth noting that this procedure shall be read and applied together with the following SIMS documents. Definitions. Accident scenario, a sequence of events that results in undesirable consequences. An incident with specific safety consequences or impacts. Administrative control, a procedural requirement for directing and/or checking engineered systems or human performance associated with plant operations. As low as reasonably practicable, a LRP, expresses that the risk level is reduced, through a documented and systematic process, so far that no further cost-effective measure is identified. Note, the requirement to establish a cost-effective solution implies that risk reduction is implemented until the cost of further risk reduction is grossly disproportional to the risk-reducing effect. Best practice. In the context of these guidelines, best practice refers to standards, procedures for controlling risk above the level provided by the application of good practice. Consequence. The direct, undesirable result of an accident scenario usually involving a fire, explosion, or release of toxic material. Consequence descriptions may be qualitative or quantitative estimates of the effects of an accident in terms of factors such as harm to people, economic loss, and equipment damage. Consequence analysis, the study of the possible extent, footprint, of harmful effects of potential incidents. For example, calculation of the size of the flammable region of a vapor cloud following a gas release, spill. Event, an occurrence related to equipment performance or human action, or an occurrence external to the system that causes system upset. In this document, an event is either the cause of or a contributor to an incident or accident, or is a response to an accident's initiating event. Event tree analysis, ETA. A logic model that graphically portrays the combinations of events and circumstances in an accident scenario, which result from an initiating event, normally equipment or piping failure. External event, event external to the system, plant caused by 1. A natural hazard such as earthquake, flood, tornado, extreme temperature, lightning, etc., or 2. A human-induced event such as aircraft crash, missile, nearby industrial activity, fire, sabotage, odd, etc. Failure mode, a symptom, condition, or fashion in which hardware fails. A failure mode might be identified as loss of function, spurious trip function, function without demand, an out-of-tolerance condition, or a simple physical characteristic such as a leak. Failure modes and effects analysis, FMEA, a systematic, Tabular method for evaluating and documenting the causes and effects of known types of component failures. Fault tree analysis, FDA, deductive technique that focuses on one particular accident or main system failure, and provides a method for determining causes of that event. FTA is a graphical model that displays the various combinations of equipment failure and human error that can result in the main system failure of interest, called the top event. Frequency, the number of occurrences per unit time, usually a year, at which observed events occur or are predicted to occur. Good practice, in the context of these guidelines, good practice refers to standards, procedures for controlling risk which have been judged and recognized by KOC as satisfying all the requirements when applied to a particular case in an appropriate manner. In this sense, written good practice is that contained in KOC standards and other engineering standards produced by globally recognized organizations such as NFPA, API, ISO, etc. Harm, physical injury or damage to health, property or the environment. Hazard, an inherent physical or chemical characteristic that has the potential for causing harm to people, property, or the environment. In this procedure, it is the combination of a hazardous material, an operating environment, and certain unplanned events that could result in an incident. Hazard identification, the pinpointing of material, system, process, and plant characteristics that can produce undesirable consequences through the occurrence of an accident. Hazard and operability, HAZOP, study, a systematic method in which process hazards and potential operating problems are identified using a series of guide words to investigate process deviations. Hazard checklist, an experience-based list of hazards, potential accident situations, or other process safety concerns used to stimulate the identification of hazardous situations for a process or operation. Initiating event, the first event in an event sequence, can result in an accident unless protective systems or human actions intervene to prevent or mitigate the accident. Likelihood, a measure of the expected probability or frequency of an event's occurrence. Process hazard analysis, PHA, the analysis of the significance of hazardous situations associated with a process or activity. Uses qualitative and quantitative techniques to pinpoint weaknesses in the design and operation of facilities that could lead to accidents. Process safety audit, an inspection of a plant or a process unit, drawings, procedures, emergency plans, and/or management systems, etc., usually by an independent, impartial team and usually problem-solving in nature. Process safety management, PSM, the application of management principles and systems to the identification, understanding, and control of process hazards to ensure the safety of process facilities, and protect employees, facility assets, and the environment. Quantitative risk assessment, QRA, the process of hazard identification, followed by numerical evaluation of consequences and frequencies, and their combination into an overall measure of risk. QRA is based on the application of engineering evaluation and mathematical techniques, ordinarily applied to accident scenarios, and is related to probabilistic risk assessment, PRA, used in the nuclear industry. Residual risk, the risk remaining after controls have been applied to associated hazards that have been identified, quantified to the maximum practicable, analyzed, communicated to the proper level of management and tolerated after proper evaluation. Risk, the risk associated with an event is defined as the product of the likelihood of the event and the magnitude, severity, of the outcome of that event. The likelihood is defined in terms of the annual frequency of the outcome. The magnitude of the outcome is defined as the number of fatalities caused by the event. The risk is the product of these quantities and is expressed in terms of fatalities per year. Note that the calculated risk is linear with respect to both frequency and number of fatalities. Public and media response to incidents shows significant aversion to accidents involving multiple fatalities. Therefore, events which may be estimated to give the same numerical risk may give rise to very different levels of public and media concern and/or impact on company reputation. There are several risk measures which are defined below. Location-specific individual risk, LSIR. Location-specific individual risk, LSIR, provides a measure of the inherent hazard associated with different geographic locations within a plant or facility. The basis for the calculation of the location-specific risk is that each target location considered is permanently inhabited by a single individual. The LSIR is evaluated, typically, at points on an orthogonal grid covering the area of interest. The calculated risks are typically presented as ISO risk contours, which provide an easily understood graphical presentation of the risks. LSIR contours are indicative of the potential magnitude or intensity of the risk, but the risks will only be realized at a given location if personnel will be present at that location 24/7. LSIR only considers those sources of risks which themselves have fixed locations. LSIR does not therefore take account of transportation risks, occupational risks, etc. Individual risk, IR or IRPA. Individual risk, IR or IRPA, is determined on a case-by-case basis for each individual working on a plant or facility. In practice, there is insufficient definition in the data which defines the durations for which people will be exposed and locations at which they will be exposed. Calculations are therefore undertaken for representative work groups rather than for every individual. The process contribution to the individual risk for a specified work group is evaluated. As the time-weighted average of the LSIR values determined at each of the locations at which the work group will spend time, risk contributions due to transport and occupational risk are also accounted for. Where personnel remain on the plant during their off-shift, risk contributions for this period are also taken into account. Potential loss of life, PLL. Potential loss of life, PLL, is derived from the work group's IR estimates. The PLL for each work group is the product of the work group IR and the number of members of the work group. Where both day and night shifts will be utilized, both will contribute to PLL. Rotations are also accounted for. PLL can be evaluated in terms of fatalities per year, but may also be expressed in terms of total fatalities over the design life of the facility. Where the difference in PLL between two design options is required, for example as part of an LRP demonstration, this is usually evaluated over the life of the plant since this facilitates cost-benefit calculations. Cumulative frequency versus number of fatalities, FN. Cumulative frequency versus number of fatalities, FN, also called societal risk, is an FN plot that plots the cumulative frequency, F, of events resulting in N or more fatalities against N. Because of the way the plot is defined, the maximum value of F corresponds to the smallest value of N and vice versa. F therefore plots as a decreasing function of N. The FN curve provides information with respect to the distribution of risk between events resulting in small numbers of fatalities and events resulting in large numbers of fatalities. Risk assessment, overall process of risk analysis and risk evaluation, which consists of deciding whether or not the risk is tolerable. Risk control, process of decision-making for managing and/or reducing risk, its implementation, enforcement and re-evaluation from time to time, using the results of risk assessment as one input. Risk estimation, process used to produce a measure of the level of risks being analyzed. Risk estimation consists of frequency analysis, consequence modeling, and integration of frequency and consequences. Risk evaluation, process in which judgments are made on the tolerability of the risk on the basis of risk analysis and taking into account factors such as socioeconomic and environmental aspects. Risk management, the systematic application of management policies, procedures and practices to the tasks of analyzing, evaluating and controlling safety risk in order to protect employees, the general public, and company assets. Risk measures, ways of combining and expressing information on likelihood with the magnitude of loss or injury, for example, risk indexes, individual risk measures, and societal risk measures. Risk reduction measure, a specific hardware, software system, or administrative control designed to maintain a process within safe operating limits, to safely shut it down in the event of a process upset, or to reduce human exposure to the effects of an upset. Risk tolerability criteria, criteria that are used to express a risk level that is considered tolerable for the activity in question. Note: risk tolerability criteria are used in relation to risk assessment and express the level of risk which will be tolerable for the activity. It is the starting point for further risk reduction according to the ALARP principle. It may be qualitative or quantitative. Safety, freedom from intolerable risk. Societal risk, the relationship between frequency and the number of people suffering from a specified level of harm in a given population from the realization of specified hazards. Tolerable risk, risk that has been reduced to a level that can be endured by KOC. Worst case scenario, a conservative, high, estimate of the consequences of the most severe accident scenario identified. Risk assessment and management process. The KOC is composed of 13 elements. Risk assessment, compliance and management is the element 3 of the KOC, and it does clearly support the implementation of element 4, facilities, design and construction, element 5, operations and maintenance, element 6, management of change, and element 7, crisis preparedness and management. Other elements in the system either require input from risk assessment and management, or they rely on this element to help define and clarify their management aims. The relationships noted above support an integrated system for managing risks throughout the entire life cycle of KOC facilities and activities. Consequently, the risk assessment and management process is essential to the objectives of the KOC HSE management system as a whole. The primary objectives of the risk assessment and management process are to identify and rank the risks so that they can be adequately assessed and managed, and to examine associated risk reduction measures to determine those most suitable for implementation. In this context, the main role of the risk assessment and management process is to assist KOC management in providing a demonstration that all hazards have been identified, all risks have been evaluated, and adequate measures have been, or will be, taken to control the risks to a tolerable and ALARP level. As part of the risk assessment and management process, a safety risk register shall be generated so as to enable identification and maintenance of risk reduction measures for ensuring that these safety risks are within limits of tolerability and ALARP as per the risk tolerability criteria provided in Appendices 2, qualitative and semi-quantitative, and 3, quantitative. The risk register template is provided in Appendix I. This template shall be utilized in all risk assessment and management activities, including the preparation of Project Safety Risk Register. Risk assessment and management approaches. Risk assessment and management process shall be used to provide an input into the decision-making process. This will enable the company's management to provide reasoned and supported arguments to demonstrate that there is nothing else that could reasonably be done to reduce risks further. As expressed in figure number 1 below, risk assessment and management methodologies need to be proportionate to the magnitude of risk being analyzed, that is, the risk assessment and management methodology utilized in each case must be efficient and should normally progress from qualitative to quantitative risk assessment, QRA. The lower levels of assessment, CRAN-square, are considered most appropriate for hazard screening. The usual approach to deciding the appropriate level of risk assessment and management detail would be to start with a qualitative approach and to elect for more detail whenever it becomes clear that the current level of detail is unable to allow for a clear understanding and assessment of the risks. However, to save time and budget, and yet achieving high-quality results, a highly competent and experienced risk assessment and management specialist may decide to start the process with Square or QRA to make the process more efficient. Regardless of the type of technique or approach used, risk assessment and management process shall not be used in isolation and in a mechanistic way. Risk assessment and management process provides only one input into the decision-making process. Description of the risk assessment and management process. Figure number 3 below summarizes the main stages in the process of risk assessment and management. As it can be seen, risk assessment and management involves a series of steps as follows. Hazard identification, based on consideration of factors such as the physical and chemical properties of the fluid being handled. Risk assessment, from the hazards and consideration of its tolerability to personnel. Risk management, consisting of reducing risks where this is deemed to be necessary. This involves identifying opportunities to reduce the frequency and/or consequence of an accident. It is clear then that the main purpose of risk assessment and management process is to identify and rank the risks so that they can be adequately managed. Each stage in the process can be seen as an opportunity to identify potential risk reduction options. The following sections present a description of each stage of the risk assessment and management process. The risk assessment and management process shall be carried out either utilizing internal resources or through an external agency, who have knowledge and experience in the day-to-day running of the plants, operations and facilities. Typically, a review team for hazard identification and risk assessment may include personnel from various backgrounds as required, for example team leader, senior engineers, operations, maintenance supervisors, process engineers, HSE personnel and inspection and corrosion engineers. Hazard identification. One key element of effective safety risk management is a systematic approach to hazard identification. The hazard identification methodology applied shall consider all the factors involved in the system under study. This shall include all modes of operation, routine and non-routine activities, emergencies, as well as external hazards. For application, methodologies, etc. related to hazard identification, the reader is referred to SIMS Guidelines KOC.SA.034 for safety hazard identification. Risk assessment. After the hazards have been identified, the risks arising from them are evaluated either qualitatively or quantitatively. This typically requires carrying out a first stage named risk estimation, which entails assessing both the severity, consequence, and frequency, likelihood, of hazardous events. The amount of detail and effort required to complete this first stage increases from qualitative, GRI, to semi-quantitative, SQUARE, to quantified risk assessment, QRA. Qualitative, GRI, and semi-quantitative, SQUARE, risk estimation. For the CRA or SQUARE approaches, this procedure provides the criteria for assessing the frequency and consequences, see Table No. 2.1 of Appendix 2. Potential consequences of an event shall be estimated considering worst-case scenario that might have resulted, not what has resulted. The impact categories are people, asset, and reputation. The frequency of occurrence of the worst-case scenario identified during severity assessment must be determined. This initial likelihood is determined after taking into consideration the existing control measures in place to prevent occurrence of the hazardous event, that is the event which is manifestation of the hazard, as well as control measures in place to mitigate the severity of the consequences. Once the frequency and consequences are determined, the risk must be estimated using the safety risk evaluation matrix shown in Figure 2.1 of Appendix 2. B. Qualitative, GRI, and semi-quantitative, SQUARE, risk assessment. The results of the risk estimated as established above, shall be compared to the KOC risk tolerability criteria, RTC, also given in the safety risk evaluation matrix shown in Figure 2.1 of Appendix 2. The risk then shall be managed accordingly. This process is called risk assessment, which refers to the process of objectively examining the risks involved in a particular activity. The objective of the determination is to ensure that the risks are fully understood. In the case of the qualitative, GRI, and semi-quantitative, SQUARE, approaches, the tolerability or otherwise of an identified risk and any associated risk-reducing measures are determined on the basis of the collective judgment of the risk assessment team and KOC current standards. In these cases, the assessment shall be performed using the Safety Risk Evaluation Matrix shown in Figure 2.1 of Appendix 2. This risk matrix is a convenient method of ranking and presenting the results. It is worth mentioning that this is a 5x5 risk matrix, and therefore, it is capable of discriminating between the risks of the different hazardous events for a facility or activity. The tolerability of the estimated risk must then be judged based on criteria given in Table 2.2 of Appendix 2. All identified hazards should be subject to an evaluation for risk potential. All activities having applicable legal requirements, irrespective of the ranking of the risk, shall have a compliance mechanism including monitoring program which shall be linked to HSE compliance register of the respective group. C. Quantitative Risk Assessment, QRA. On the other hand, if a QRA is required, then SIMS procedures KOC.SA.040 guidelines for quantitative risk assessment and KOC.SA.041 for rule set for quantitative risk assessment shall be applied. A detailed description of these criteria both for individual and societal risks is given in Appendix 3. Risk Management. A. Overview. Risk-reducing measures shall be introduced if the risks exceed any RDC, or if there are other reasonable measures that can be justified. In any case, consideration shall be given to reducing risk to a level deemed alarp, reflecting among other factors local conditions and circumstances, the balance of cost and benefits and the current state of scientific and technical knowledge. To reduce a risk to an alarp level involves balancing reduction in risk to a level objectively assessed, where the trouble, difficulty and cost of further reduction measures becomes unreasonably disproportionate to the additional risk reduction obtained. This process is described in detail in SIMS procedure KOC.SA.042 for guidelines for as low as reasonably practicable, alarp, demonstration. Particular attention shall always first be given to risk reduction measures which have the effect of eliminating or reducing the frequency of hazardous events occurring. The use of inherently safer design principles, see SIMS procedure KOC.PS.006 for inherently safer design, to manage risks is preferred. A progressive approach to risk reduction shall be adopted, giving attention first to those measures which have greatest effect in risk reduction for least effort. Successive evaluations of risk reduction measures shall be undertaken until a point is reached where all the RTC have been satisfied, and it has been demonstrated that the risks are tolerable and alarp. B. Barriers to hazards. Risk assessment shall consider the barriers in place, see Figure 4 below, how these are intended to function and if they function. Some barriers are installed to individually stop the hazard from releasing. Other barriers will only reduce or mitigate the consequences of the released hazard, and a series of sequential barriers is required to fully eliminate the consequences. If all the barriers are in place and functional, the consequences of the hazard should in theory not occur. Similarly, if any of the barriers is not functional, then the consequence size will ultimately depend on the specific effect of the non-functional barrier. C. Manage the risk to acceptable level. After the risk has been identified and analyzed as per above, management decides what corrective action, if any, is necessary to manage the risk at a tolerable and alarp risk level. For more detail, refer to SIMS procedure KOC.SA.042 for guidelines for as low as reasonably practicable, alarp, demonstration. Depending on the nature of the specific hazards, this may require different steps too. Eliminate the hazard. Prevent the hazards from occurring, eliminate, or to reduce the likelihood of the incidents. Reduce the consequences with other control measure. Mitigate the consequences of the hazards which are inherent to the type of operation or working environment and which cannot be prevented altogether and have a chronic likelihood to develop into incidents with harmful consequences. Recover from the consequences of incidents. Recovery and damage control measures should be developed for all potential emergencies with the aim to prevent escalation, for example from critical into severe or worse severities. In any case, concerned asset management shall formulate a corrective action plan, which shall include the agreed actions, responsible persons, and completion dates. In formulating these plans, it is important to realize that risk management measures include organizational and system measures, such as engineering control, such as detection, alarm and shutdown system; administrative control, such as standing instruction, job rotation, warning signs, notices etc. Personnel training and qualification procedures. Change control and documentation procedures. Quality assurance, maintenance and inspection procedures. Periodic personnel medical checkups and medical treatments such as vaccination, immunization. Follow-up that includes regular updates for progress to ensure actions are closed per the plan. Risk monitoring. The responsibility for implementation of additional control measures as well as maintenance of existing control measures must be specified. Responsibility must be assigned to a specific designation. Where additional controls are in the form of a program requiring time and resources for completion, the target date for completion must also be specified. Documentation. The key information and the decisions made in the risk assessment and management process shall be fully documented in an ordered and comprehensive manner. The documentation shall register the various decisions made during the process as well as the basis for those decisions. This documentation shall be reflected in a risk assessment and management report. This report shall be written in an understandable manner to all personnel involved in the decision-making process. As a minimum, it shall include objectives, scope and limitations, a description of the system under study, assumptions and premises, main contributors to the risk, sensitivity analysis, if required, conclusions from the study, risk reduction measures recommended. The risk assessment and management report shall be approved by the asset management. The asset management in turn shall prepare an implementation plan for the risk reduction measures agreed and a follow-up plan, which will be included in the HSE Group audit program. On the other hand, the results of risk assessment and management studies and activities shall also be recorded in the Safety Risk Register, SRR. Additional information on the management of the Safety Risk Register, as well as the SRR template, KOC.033, are provided in Appendix I. Updating and verification. As a minimum, risk assessment and management studies shall be updated once every 5 years. However, depending on the magnitude of risks and the potential consequences of hazards, the risk assessment and management studies shall be periodically reviewed by competent staff. The reviews shall involve those parts of the organization which are involved in day-to-day management of these hazards, that is, the operations and maintenance functions. As a typical issue for these reviews, it shall be verified if the base assumptions have changed since the original design was implemented or since the risk assessment and management study was done. For example, has the plant, equipment performance lived up to the expectations of the original design in terms of accidents, incidents and equipment uptime? Has the oil, product or equipment price changed significantly, that is, what is the current cost of production loss and or equipment replacement? Have there been significant and unexpected changes in agent or technical integrity of equipment, for example excessive corrosion, wear, tear? Have there been significant hardware changes, and if so, have the risk associated been adequately reviewed in the context of previously defined risk levels? Is the average experience level of plant operators and maintainers still the same? Can new technology provide lower, and possibly cheaper, alarm levels? Have legislation and or public perceptions changed regarding what is now considered tolerable, intolerable? Have there been changes outside KOC influence which could affect overall risk levels, for example population buildup around facilities in previously isolated areas, increased road traffic, security aspects, etc.? Specifically, Those issues which are managed at ALARP risk level but still remain toward the upper end of the ALARP region, shall be reviewed on a minimum frequency of once a year. Verification of risk assessment and management studies shall be performed by Assets Directorate's HSE team's competent personnel, and as a minimum the following aspects shall be verified in this process. The risk assessment and management study is adequately scoped in accordance with the needs and objectives. The risk assessment and management study has thoroughly followed the process established in this guide. The risk assessment and management assumptions and premises are credible. On the other hand, risk assessment and management process shall be systematically audited by HSE Group with the aim to achieve the following objectives. Ensure the effectiveness of the studies and their adherence to this guide. Ensure that risks are being properly managed. Risk communication. Risk assessment and management activities and results are of limited value if not communicated properly to internal audiences and, where appropriate, external audiences. The internal audience is comprised of KOC employees and relevant contractors. Risk communication is an asset management responsibility, which should be fulfilled through ongoing communications to ensure that all personnel are aware of the risks, and changed risks, plus their roles and actions to be taken. The external audience includes the general public that can be impacted by assets operations and, also, appropriate regulatory agencies for emergency preparedness purposes. Abbreviations. ALARP, as low as reasonably practicable. API-American Petroleum Institute. BRA, Building Risk Assessment. OD, Explosive Ordnance Disposal. ERM, Enterprise Risk Management. ETA, Inventory Analysis. FN, Cumulative Frequency versus Number of Fatalities. FMEA, Failure Mode and Effect Analysis. FDA, Fault Tree Analysis. HAZID, Hazard Identification Study. HAZIP, Hazard and Operability Study. HSE, Health, Safety, and Environment. SIMS, Health, Safety, and Environment Management System. IR, Individual Risk. ISO, International Organization for Standardization. JSA, Job Safety Analysis. KOC, Kuwait Oil Company. LOPA, Layers of Protection. NFPA-National Fire Protection Association. PHA, Process Hazard Analysis. PLL, Potential Loss of Life. PSM, Process Safety Management. CRAE, Qualitative Risk Assessment. QRA, Quantitative Risk Assessment. RTC, Risk Tolerability Criteria. SQUARE, Semi-Quantitative Risk Assessment. SRR, Safety Risk Register.
Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.